Welcome to the Explainer. We're moving way past just simple rote memorization today. If you're prepping for the Microsoft AI-200 exam, you already know the drill. There are tons of concepts and a whole lot of terminology. But today, we're going to truly understand the core building blocks of artificial intelligence by breaking down 10 specific questions, questions 11 through 20 from the practice test. We aren't just hunting for the correct multiple choice letters here. We're going to map out exactly how these systems actually work under the hood. Here's our roadmap. Number 1, AI language and storage. 2, shaping AI model behavior. 3, ensuring safe and responsible AI. And 4, tallying your final score. Man, the practice exam jumps around a lot, doesn't it? 1 second you're dealing with parameters, the next it's tokens or image recognition. It kind of gives you whiplash. But don't sweat it, we're going to break these 10 questions down systematically so you actually grasp the mechanics behind the right answers. By the end of this, you'll see exactly how they all connect. Section 1, AI language and storage. How AI actually reads and holds data. Okay, so question 12 hits us with tokens. What is a token? It's simply a unit of text processed by a large language model. To really wrap your head around this, don't think of a token as a full word necessarily. It's more like a bite-sized chunk of text. Sure, sometimes it's a whole word, but often it's just a syllable or a few letters. When an AI digests your prompt, it doesn't read the way you and I do. It chops the sentence into these fundamental, math-friendly units to process the information. Right, but what if that text isn't typed out neatly for the AI? What if it's trapped inside a picture? That's exactly the scenario posed in question 13. If you have an image of a street sign or a receipt, how does the AI actually read it? The answer is Azure AI Vision, specifically using OCR, or optical character recognition. You can basically think of this as the model's eyes. It scans the pixels of the image, recognizes the shapes of the letters, and yanks that printed text right out so it can be converted into tokens. It totally bridges the gap between the visual world and the text-based AI world. Which brings us right to question 14, and embeddings, representing text as vectors for semantic search. Look, once the AI has tokens, it has to figure out what they actually mean. Embeddings are literally like a massive GPS coordinate system for words. They turn text into mathematical vectors, and words with similar meanings get grouped closer together in that math space. This is the exact magic that allows AI to pull off those incredibly intelligent semantic searches, rather than just doing a dumb keyword match. And that flow brings us perfectly to question 15. Where do you store those embeddings? The answer, of course, is a vector database. Once your text is mapped out into those mathematical GPS coordinates, you can't just toss that data into a regular spreadsheet. It needs a highly specialized filing cabinet built exclusively for multidimensional numbers. That's your vector database. It lets the system instantly recall and compare concepts based purely on their meaning. Section 2, shaping AI model behavior. Let's look at how we control those outputs. Before we can shape any output, we need a way to actually talk to the model. The primary bridge for that interaction, which comes up in question 19, is understanding which API handles the actual dialogue between you and the AI. And that's the Chat Completions API, used specifically for generating conversational AI responses. It is tailor-made for that fluid back-and-forth dynamic. It actually remembers the context of your chat, meaning you can ask follow-up questions naturally without having to re-explain yourself every single time. Now, when it's generating those responses, you have levers you can pull to change how the AI speaks. Question 11 is all about the temperature parameter. Think of temperature as your AI's spicy dial. It controls the creativity and randomness of the output. Turn it way down near 0, and the AI is strict to business, super focused, literal, totally predictable. But if you crank that dial up, the model gets way more creative, takes imaginative leaps, and uses wilder vocabulary. You dictate the flavor. Question 18 takes this deeper with fine-tuning. We're contrasting a standard, pre-trained model with a fine-tuned one. Imagine a pre-trained model as a fresh college grad. They have a massive amount of general-purpose knowledge. Fine-tuning is when you take that model and train it further with your own domain-specific data. It's like sending that grad to highly specialized job training, so they completely master your company's proprietary jargon or workflows. You're specializing its behavior. Section 3, ensuring safe and responsible AI. Setting up the vital guardrails. Question 16 tackles the classic AI pitfall, the hallucination, which is simply a confident but completely incorrect response. Remember, these language models are ultimately just predicting the next most likely word based on patterns. So sometimes, especially if that temperature dial is cranked up too high, they'll spit out something that sounds incredibly authoritative and plausible, but is literally just made up. It's a massive vulnerability you have to watch out for. To combat risks like hallucinations and bias, questions 17 and 20 highlight two absolutely essential safeguards. First, prioritizing fairness as a core responsible AI principle. AI systems must be designed to avoid amplifying societal biases. Second, utilizing content filtering to actively detect and block harmful content. You have to put robust filters in place so the AI isn't absorbing or spinning out toxic or dangerous material. Fairness and filtering are your non-negotiable guardrails. Section 4, tallying your final score. How did you actually do? So, we've successfully traced the data flow all the way from raw tokens up to responsible outputs. The source material challenges you to score yourself out of 10 on the specific batch of questions. Be totally honest here. How many of these underlying concepts did you genuinely grasp before today? Did you actually know the difference between an embedding and a token? Did you fully understand why temperature matters? Tally it up. Keep learning, keep growing, and prep for questions 21 through 30. I'd love it if you dropped your score in the comments below to keep that momentum going. But I want to leave you with this one provocative thought to ponder today. When you take these practice exams, are you just memorizing the correct multiple choice letters to scrape by, or are you actually taking the time to build the deep architectural foundation required to help shape the future of AI? Keep growing, and I'll catch you in the next explainer.